And we're back bringing you the daily space weather. That's the past couple of hours from the GO 16 SUVI. And if you look down there in the lower right, which would be the southwestern limb region, certainly some plasma instability going on down there around sunspot 3712. It will, going forward, be the most likely place to see a large solar flare. And let's break it down. Yeah, so a bunch of plasma moving around down there. Also some plasma motions in the north central region. We'll get to those as well. That's the past 24 hours from the SDO. And we've got a bunch of unnamed sunspots, no less than 3 unnamed sunspot groups in that eastern limb. So as these 3 major sunspot groups set in the western limb, especially the likelihood of the the southernmost group there, it's going to be the most likely to produce large flares, especially as it reaches proximity to that limb. That'll also increase the likelihood of proton events, otherwise known as solar energetic particles. So we might see some polar radio blackouts from that. Now, we've got at least 3 new unnamed sunspot groups in the eastern hemisphere as well. So way up there above the Earth scale, there are 2 new groups up there, and having just risen over in the southeastern limb, way down south below the Earth scale there, a third. So 3 sunspot groups to get named by tomorrow. So that would explain the decline in the sunspot number since yesterday. That was pretty weird. We thought it would have gone up for sure, but it didn't because groups haven't been counted yet. So they just mustn't have been on the Earth part of the disk for more than 12 hours or something like that. And thanks for tuning in to the Smash News Network least busted name in news. These are the past 24 hours. We thought we'd show 1700 angstroms here for once, just to get you a nice view of all those major sunspot groups in the west. And right toward the end of the video, you'll see several new sunspot groups rising in the east. And welcome to summer, the first full day of summer. How are you liking it so far? The 10.7 centimeter radio flux has now risen to 203 solar flux units. 203 is the radio flux number. And there it is over the past year, depicted by that black line, courtesy of solon.info. If you're wondering what the radio flux is measured in, it's in units called Jansky. So 1 solar flux unit is equivalent to 10,000 Jansky. You can read about Jansky on Wikipedia if you like. It's just a measurement of radio flux density. So feel free to check out the article if you like. And down at the bottom, you'll even see a reference to the solar flux unit. Space Weather Enthusiast Dashboard not forecasting any geomagnetic storms, and I'm not either. They are looking at the possibility of a little geomagnetic unrest from a coronal hole high-speed stream. We'll have to see what the impact of that is. It depends on things like the solar wind density, the solar wind velocity, and the magnetic field strength. Yes, the magnetic field strength is the crucial component. So, not a lot of action there on the Enlil spirals from NOAA or ESA. Again, no new space weather on the way at the moment. Things are pretty empty between Earth and Sun at this point. So there you can see ESA's forecast for that coronal hole high-speed stream as well. Let's move on to some more simulations. Here's a model for you. It's the Geospace Magnetosphere movie. And we have very geomagnetically calm conditions right now. So no fast solar wind, no dense solar wind. It's weak sauce solar wind. Past 4 hours of Earth's magnetic moment from space, the past 4 hours of Earth's magnetic moment from the ground. So, yep, not scary, not spooky. The pole shift, not scary, not spooky. And, yeah, people seeing auroras at low latitudes, also not scary nor spooky. KP index is at 0.66. 0.66. I mean, it's really .66, so it's like 0.6666666666, which it rounds to the nearest hundredth of a KP index unit. Again, solar wind is pretty weak here. So the ACE only getting about 2.3 protons per cubic centimeter. The Discover only getting about 1.4 protons per cubic centimeter. Make it 1.5. And now solar wind dropping below 400 kilometers per second. So very slow and very diffuse. The GOES 16 and GOES 18 had to do some maneuvering, though. As you can see there, some arc jet moments as they turn on their thrusters to maintain their geosynchronous near equatorial orbits. Next is our heliosphere magnetism. Earth is in a North Pole magnetic sector, and it looks like it will be an extended period in that North Pole magnetic sector. Here's our line of sight plot. And frankly, not too exciting at the moment. Moving to coronal holes, we've got some. We're not expecting any big fireworks from them either. But that is the past 4 days. We'll stop it on the last frame. You may want to see it. There you go. There's the distribution of coronal holes. And here's our SDO 211 angstroms wavelength. Now, this wavelength is also very good at showing filaments. And you may see some major plasma motions there just north of our Earth scale on that imagery. If you're not able to see it there, well, don't worry. We'll zoom in a little bit closer here because it's well worth a look. You can also see the Michael Jordan filament there, just moving past the center of solar disk in the southern hemisphere. But if you watch just north of the Earth scale there, you'll see a lot of plasma motion happening there. That's the same sort of thing we have happening down in the southwest. So lots of filaments are moving around, aka becoming unstable, because they'll be experiencing a very bumpy ride in terms of the magnetic fields, which suspend them and allow them to defy the sun's gravity. So here is that's the Michael Jordan filament. We named that one a few days ago, since it's one of the largest ones that has been on the Earth side of the solar disk for the past 6 years. And it's not looking very unstable. So, unfortunately, no forecasts for it to blast off. And next, sunspots. Yeah, sunspots. You know, those things. Those things there from SDO. Sunspot number has dropped since yesterday, which seems unfathomable. If you watched yesterday's daily space weather video, you'd know why. But yeah, it seems bizarre. But we may see sunspot number rise as much as about 50 sunspots tomorrow, because again, we've got 3 groups that have not been named yet in the east. So yeah, we could see sunspot number rise by 50 here. Probably see more like about 25 to 30 new sunspots counted in the next 24 hours. Flare probability is really high, and it's mainly associated with sunspot 3712. There you go. Once again, a 60% chance over there on that western limb, the western limb. But the new sunspot that rose in the southeast is also looking promising. So, and of course, 3719 actually has produced the largest flare in the past 24, which we'll get to here in a moment. So there's a 24-hour SDO video. Again, there may be 2 new named sunspot groups in the northeast, and there will certainly be 1 new named sunspot group in the southeast in the next 24 hours. So that'll be a lot more new sunspots getting counted than we have setting in the northwest. Here's our magnetogram. And most of those groups are pretty stable here for the past 24 hours, as that is the time frame depicted on the imagery. After sunspots, we're moving to solar energetic particles and flares. As far as solar energetic particles, like I said earlier, we do have a higher chance now of seeing some SEPs, but at the moment, they're at baseline levels. Largest flare of the past 24 was an M5.56. A 5.56. I'm telling you, that's what it is. Believe it or not. Believe it or not, folks. An M5.76. I stand corrected. So, and again, that came from the southeast. So maybe that was unexpected. I found it to be a little bit unexpected. So that would be in your screen lower left. Come back now. There we are. So late in the day yesterday, around 2300 Universal Time, we did see that M5.76 flare. For the next 24, the most likely place for large flares is that western limb, despite flare production in the east. Statistically speaking, it's more likely to see a large flare in the west, based on magnetic fields and proximity to the limb. Here is our eastern limb. And since that new sunspot in the southeast is our T-mass, we'll show a close-up of it. There you go. That's a pretty good action shot. So southeastern limb is the second most likely place to see a large flare. Most likely place to see a large flare is that western limb. And once again, there's the equatorial view. Let's do a solar system forecast. By the way, this is from theplanetstoday.com. I like their model. It looks pretty sweet. Here's our 1 week forecast. A quick view of a star chart. This is what's going on above my head. If you want to make your own, skyandtelescope.org. Just input your zip code or your town or whatever. Astronomy photo of the day is multiple wavelengths here from Hubble Space Telescope. It is ultraviolet spectra of New General Catalog 1546. It's about 50 million light years away. It is a somewhat edge-on spiral, which is slightly tilted toward our location. apod.nasa.gov if you want to check it out yourself. Moving on to CMEs. CMEs, coronal mass ejections, when the sun blasts material out of its atmosphere. For the past 24, it's been pretty calm. So no Earth-side events. The events you see there are far side. Far side, like the comic. So there's Blasco C2 and C3. Let's move on to Stereo A, which really isn't particularly exciting either. It's not really showing us very much because there hasn't been a lot going on. But we'll show our custom coronagraphs just to sort of, for sake of completeness, so that's another 24-hour video at 30 frames per second. Lasco C3 in blue, C2 in red, and the SDO 304 angstroms wavelength in the middle. Also Venus over there to the left. Here we've zoomed in and we've added the 193 angstroms difference imagery of 60-minute running difference there from SDO. Just to sort of show you that there are no filaments associated with those CMEs. So those are not earthly directed. We'll also zoom in a little bit closer here. Let's actually cut to our... We'll come back to filaments at the end of the video. First, Big Bear. So there's that Michael Jordan filament. It is a bear of a filament, indeed. A grizzly. They're larger than polar bears. Polar bears I find more interesting, but grizzlies are larger. So there is our grayscale imagery as well. Some prominence is there, both rising in the east and setting in the west. These are the past couple of hours from the GOES 16 SUVI 94 angstroms wavelength. And eyes on that southwestern corner, right down here, the southwestern corner, right in the closest part to me. That is where it is very likely to see an X-class solar flare. Let's do bonus features briefly. We ain't got no satellite charging hazards. The GOES electron flux here, the GOES 18's moved into warning levels. So we may see some additional GPS errors that we haven't been seeing for quite a while here, as we've had extended periods of low electron flux. That's a 7-day graph now coming back up off the floor. NOAA's forecast is for them to level out around this level. No argument from me this time. We'll show the layer where it's measured as well, the vibration of the gas in the ionosphere, which is at about 300 kilometers of altitude. If you're talking about the F layer, which we are, here it is, the ionosonde. Anomaly in megahertz from the 30-day median. Note the South Atlantic anomaly remains around the coastline of South America, where it intersects with the 45 degrees west longitude line. Yeah, the South Atlantic anomaly, it's moved hundreds and hundreds of miles. Total electron content and maximum usable frequency are next. That is our global ionosphere nowcast. And yeah, we are seeing some higher likelihood of large GPS errors, especially in the Pacific, it looks like. Here are our high-res images. And like I said, a new promising sunspot has risen there, and oh, it's not looking so promising now. Oh, geez, that might even... I think it's beta class, but, well, at least those sunspots are north and south of each other. That's always better than east and west of each other. Are they opposite polarity, or what's going on with that? They look like they are the same polarity. Huh. Let's try that again. Let's get a little closer here. There we are. And what do you got? What do you got? That's a beta class sunspot. And it's a beta gamma class sunspot. So, yeah, that's a good thing. It's slightly more likely to produce a large flare than if it was only an alpha class sunspot like this one in the northeast. That one there is not a big flare player. But these over here, especially this one, is a big flare player. Let's try that again. We'll get them both on screen for you here. There we are. So that's what's going on. Watch that western limb. X-class flares and solar energetic particle events could be coming our way, as well as massive coronal mass ejections. Likely, very likely, there's about 100% chance of major CMEs in the coming 24 hours. So let's cut to filaments. We'll close out with those. Our custom SDO images there, that's 304 angstroms plus the 193 angstrom 60-minute running difference. So quite good at showing filaments. Once again, the massive Michael Jordan filament. It's millions of kilometers in length. And once again, back to square one, the SDO 171 angstroms wavelength. Thanks for tuning into the Space Weather. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.